Good morning. Yeah, so as an entrepreneur, you have to have a lot of energy. So I have my mobile phone. Who are all having mobile phones? Can you just show? Keep social distancing a little bit. Okay, keep it a little away. Okay, so I think I am supposed to introduce myself. I am Suresh Nair. I was with Government R&D Lab for 13 years. Then I became CTO of a multinational company. I spent around 20 years there. Then meanwhile, I started two companies. I founded two companies. So one is Design Alpha, another one Biophoton Technologies into Biophotonics. Today, I'll be talking about product development life cycle. I will keep that going in mind so that, I will talk about not the simple products, but maybe very complex and, which requires a lot of certifications and all. Let us focus on the innovation. This is what I think you talk about every day, what is innovation and all. So, this normal definition is this is the process of translating an idea or invention into a product or service. That is what is called innovation. But I think as Vivek was talking about, I have a little bit difference in definition. I call it as an innovation only when this process of translating an idea or invention into a product or service for which customers will pay. This is very important. See, when we do BTech, MTech, PhD and all those things, we develop some sort of expertise in some area. That is our comfort zone, because we know what is there and also we build our expertise in that, and naturally we will think like we will come up with a product in that area, okay, of our own wish, and you are expecting that customers will buy. That is not going to happen, okay. So that is why unless there is a customer to buy your product or service, it can't be called as an innovation. So this has to be kept in mind, okay. So this, I think earlier Vivek was also focusing on that one. That is one of the major facts. Coming to innovation, when somebody falls down and breaks his hand, we put plaster and things like that, and youngsters like to put the plaster instead of that sling because of this one, you can write I love you, this, that and all those things, they enjoy that word. So sometimes, you feel like you should break your hand, but, in India especially, when you go out by putting a sling, you have to explain to everyone what happened. Because the first person whom you meet, they will ask, what happened, kya hua? Like, you have to tell. So think of the energy you are putting out to explain what happened. That is too much. So I was thinking like, why don't we have like this? And the sling itself, you print what happened. Okay, for example, dog bite, or you fell down, or the third one during games, and the fourth one I reserve for some family problems, okay, which you don't want to expose it. So think of the energy saved. So this is also on a lighter side, but this is an innovation, okay. So let us enjoy this talk, otherwise, you feel like, I'll be talking something theory. This is another important slide. There are around 57,000 startups in India now. Government funds everything, left and right, good ideas. But if you look at, I am from the hardware background, I think, sorry about some of the software guys here. On the hardware background, if you look at how many successful products, commercial products came out of these startups, if you look at very, very less. So there was a study done on that one. What is the reason? We call it as a postmortem. Okay, what happened? Why startups fail? So you can see that 42% of the reason for failure is no market need for the product they built. So that is what I told you, customers will have to pay. Okay, so you are coming up with a product where the customer doesn't need it. So that is one thing very, very complex. Second one is ran out of cash. You get some 50 lakhs or 1 crore type of initial investment. So you spend that without really looking at, I will come to those things a little later. Then you will run out of cash. You can't really come up with the next version, you get stuck and things like that. So like that, not the right team. Right team is like how I think people might have already talked about that one, how to form a team. It's not like your friends, in the class will form a team. You have to really identify the complementing capabilities, expertise. It's not like I am an electronics engineer, another electronics engineer who is my friend, I will make it, or my brother, sister and things like that. So it has to be well thought of. I am not getting into that. Then get outcompeted, all these things. So there is no single reason, but it's a cumulative reason. Many of these things can happen. So you have to be very, very careful. Now we have failure reasons are known. So you have to now learn from that one. Okay. Now the first thing will come, how will I get a good idea? I think most of you may be having already good ideas, but I will talk about from my experience. I have been working on the products which are making social impact, like disabled people, blind, handicapped and all. So that is another area. I am not focusing that on today, but we try to put down based on the study which are the areas now possible, and you can see thousands of startups are working in these areas. So there are opportunities in all these things. I am not getting into all these things. I think you also may be working in some of the things which is a very favorite one, physical disability. How can you give back to the society? So that is another aspect. Then clean energy, I think somebody may be working in your group also. In health, a few people may be working. So there are a lot of enough opportunities. Only thing is you have to open your mind and do a study. But I am not getting into that one. I will have it later on. Sorry. What I thought is, like, from my own case studies, I will just show one or two slides how the innovation was translated to multi-million business. Okay, so that will give a sort of a inspiration or motivation. This is my story. Okay, so like Boeing, earlier, maybe some 15 years back in this story, we were called by Verizon. Verizon is one of the very famous network provider in USA. So they called a lot of companies as a challenge, like they have a problem. At that time, fiber to the home was coming up. Now I think everybody, you may be having fiber to the home. At that time, fiber to the home was first concept. At that time, they wanted to, a few companies, they threw up a challenge saying, like, they wanted some system, hardware system, which can save lot of manpower when they install the fiber, when they give the connection to the to the home. So many people were called in. The idea here is, like, I will be focusing, I think, more on the fiber here, because that was one of my favorite area. When you want to connect to fiber, you cannot just connect or twist or something like the copper one. You may be knowing, you have to align properly, you have to fuse it. Okay, otherwise you have to put a connector. So fusing is better because loss is less. So they always preferred fusing, but when you want to do fusing, a technician has to go there and put the fiber, fuse and all. It takes a lot of time, manpower. So they were asking us, can you come up with a solution which will save this manpower? So another option is connector. Connectors were also available, but those were giving. So there was a challenge, like, you can come up with a connector which will be very less loss. That is one thing. Then this is one unit. Actually this was first installed in Manhattan, where it was we were also there. So in a high-rise building, they will put a common unit somewhere on the floor, and from here all the apartments will be connected through fiber. So they don't know where this will be put. Okay, so the position will depend on various factors. So they wanted a flexible unit which can be put. So I will stop there on the explanation, but you can see Japanese customer, the vendor, how they have come up with, US customer, how they have come up with, this is our solution. You can see the spool of fiber is required, like in our extension cord. The same thing. We did lot of search on that when we went to fire engine office to find out how the hoses are kept and things like that. So what we did is, like, all the spool inside the box, whereas the other people, they put it outside the box, so that, somebody can cut it and many things can happen. So that is why the customer Verizon selected our product here. So this is only through Indian innovation. You have to think, how can we come up with a better product? So that was one thing, and for 15 years this manufacturing was going on. So it has undergone all the tests and things like that. So this is one way of, thinking differently. Second, we have patent and all those things. Another one, how simple can be an innovation, even to grab business. Again, I am talking about most of them US business. See here also, this is also connected to the fiber optic network only. normally like you see the telephone, what is that called, the boxes on the roadside, like the when your telephone doesn't work, the operator will come, technician will come and do connection something and all. So these are all on the roadside. A similar thing is happening for fiber also when the fiber to the home was coming up. So the normal the rack was like a box, and inside there is a sort of a panel with the hinges. You just hinge open the panel so that you can access the backside. That was already there. So what we did, because we have to come up with some USP, unique selling proposition. You can see here, we made in such a way that this, instead of here hinge and opening, we made an axis like central, and it will rotate within the box. So the USP, what are the USP? When you go to a customer, you have to tell what is your USP, because while snow is there, when you open this with the hinge, this will be coming out and there can be snow there, it can affect. But here I am always keeping within the enclosure. This will never come out of the enclosure. This is a simple thing only. But you have to, think in that way, think differently. That is what I want to emphasize. Another case study was there, we were always telling like, you need to know what customer needs, then only you have to develop. I have another story also, that also is possible. We came up with the innovation and created the market for that. So this is also possible, but this is a very, very risky thing, because you are investing a lot of money unless you are very sure that there will be an customer here. So here again on fiber optics, I will come to other areas also later on. When you read any textbook on fiber optic communication, they will put like high signal security. All defense networks are connected using optical fiber. You cannot really tap, or normally you cannot tap it. Okay, but we have shown that that is possible. Okay, because it is already existing. There were, for example, from sensitive data you are getting by an authorized user gets it, a copy can go to an intruder also. We have demonstrated that one. So using a very simple product, what we do is the same fiber, we make a small bend. When a small bend is made in a fiber, light radiates. Okay, that you can collect it and then you can get a copy of this one. So this we have proven. Okay, and we went to the defense, Indian defense, because we didn't want to give to anyone else. We went to the Indian defense and we demonstrated in their file. We have taken their copy of the file and showed them. But only thing is like, lot of things to be discussed, like the protocol, encryption and all those things, leaving that one, but this is possible. So what we did was like, we have come up with a system, we call it a fiber intrusion proof system. If you put these systems across the fiber you want to protect, this will automatically prevent any such data loss here. So I can talk about for 1 hour for on this one how we have done, but this was done. So we developed the product, went to these defense, Indian defense. Now I can't tell where these are all installed. Throughout the country this product is installed. So from a simple idea, if you believe the textbook saying like its signal integrity is there, fiber can't be tapped and all, then gone, that's there. But can you think something differently? Can a fiber be tapped? Because there were some reports in marine, underwater sea and all, lot of spying happens. So this happens because of this one, So it is not an unknown thing, but you have to build your idea and come up with a business. But this requires a lot of initial investment. Till you develop, nobody is going to buy. So that is a risky thing, but this is also possible. Yeah, another innovation, like in classes like this and all, you always wanted to sleep, especially after the lunch and all. So I have in my box something called a sleep safe sticker. So just take that sticker and put on the eyelid and you can sleep it. Nobody will know. Okay, it is like your eyes are open. Okay, I have in my bag also, I can sell it. So doze off in class or at work, it is in very much demand in such beautiful sessions. I have a self-check on your innovative. You are all having innovative ideas, so you have to, first you have to know all these ideas are really workable. Okay, so those who are already having an idea, just leave it, but I will just ask you to do a self-check. One is originality. Originality doesn't mean that which is non-existent you are going to come up with. I always believe in incremental originality. Okay, like you have to add a little bit more on that what is not existing. It's not like entirely new things you are coming up with. Okay, this is originality that you have to do yourself. Why I'm saying is like, I have been sitting in many panels also. People read some paper and all IEEE paper and come back and show it as their idea. See, the panel will not know at that time because we have, many of the people have limited this thing. But you have to think you are going to put your career into risk on that one by doing that. Okay, that's what you have to think if you are very serious. Second one is prior art status. When you are doing something, you have to know what people have done till now. That is very important because you have to stand on their shoulders and think. That's why prior art. Otherwise, it will happen like another product, Me Too product is come out and all. So you have to be very careful. So you have to do a extensive work on what has been done till now in your product. People tell like nobody has worked on this and all those things that we can claim always. But these are all self-check. So for you only. Patentability, many patent, it is very important because when you are starting a company, people will ask how many patents you have and all when the valuation comes. Otherwise, I don't mind anything on patents and all. That is not a difficult thing also. Okay, so you can always get. So you have to see. Market analysis, competitive, I think you already had a lot of sessions. I understood that. You need to have an idea of development. I will talk about more details on that. Yeah, this is very important. Product cost. See, when you are starting developing a product, you don't have a product cost because normally what is done is you do the design, take the bill of material, add the cost and all those things. But you need to have an idea of what should be the product cost. Okay, that is also, we call it as a design to cost. I will come to that one. So this is very important. Why? Because you have an idea of what are the competitive products and what can be my product cost. But product cost is not a bill of material cost. I will explain that also, and time is there. Repeatability. This is very, very important. When we do any experiment in our lab and all, and you want to demonstrate to the teacher, only you can demonstrate with your circuit. If you give to your friends to demonstrate, it may not work. Because we are in that way, like touch here, there and all, how it is, it will work, okay. But when you are developing product, that is not the acceptable one. Why? You are MTech, PhD and whatever you have and all the Maxwell's equations and all those things, When this is being manufactured, the manufacturing is going to be done by an ITI guy. He doesn't know Maxwell's equation and your theory and all those things, how your system will work and all. Okay, so you have to design in such a way that when the ITI guys assemble, it should still work. Okay, I am talking about electronics, but it is true for mechanical or any other thing. Okay, so one example I will just give. The resistor, those who are electronics engineers, we have resistor and we have a tolerance ring. The tolerance ring, gold ring, silver ring and all, long back I don't know whether you have really used after that one, after, the BTech first or even pre-degree class and all, why that is required and all. But when you are designing a product, you have so many components with these tolerances. It can happen like your amplifier may oscillate because of all these tolerance issues. So you have to really do a tolerance analysis. So you may ask, okay, I will put the tight tolerance for everything. Then the cost will go very high. So you have to be very, very careful. Similarly, those who are in mechanical, whenever you can, in the SolidWorks, you can draw very good cover and all. Tolerance, nothing. But when you go for manufacturing, they will ask, what is the tolerance, plus or minus how much? So you have to give that tolerance. So if two parts are there and the tolerances are not matching, it may become loose or tight or whatever it can happen. So these are all to be understood very well when you are coming up with a product. Manufacturability, that's what I am talking about, whatever you solder may not be manufacturable in the normal manufacturing way. Say, then sustainability, like what next you have to always think of. So this is the stages involved in a concept to product life cycle. It need not be in this way. I normally follow this one. I will explain each one of them. Concept is there, your concept. First thing is that concept to be proven to others, that is proof of concept. When you are doing proof of concept, you can use lab power supply, you can use lab equipment, signal generator, whatever you want, or any of the available equipment, okay, because you are showing to prove the concept on that. Once that is done, then you move on to design. I think earlier also a few questions were there. I always think like, never ever think like I will do another design again. Then it is going to be a problem. It will take time, energy, money, and all those things. How many iterations? Somebody was asking that one. So when you are at this stage itself, you should think like, this is my first thing which is right, first time right. Okay, I'm not going to change any other thing. So why I'm saying is like, you give enough time to think it over. Okay, it may take 1 more month or 2 more months. It doesn't matter. It will save another year for you. Okay, so you give that much time on this design. Then proto build. First thing is, once the design is done, the design has to be in the same form and fit of your final product. Okay, same form and fit. That's what I am telling. Think first time right. I am going to make first time right. It may not work, in first time right, but you have to plan like that. The first thing what you make is prototype. You give this prototype to others, your potential customers. If you don't have a customer, somebody who can be your customer, give them, get the feedback. The first proto, we call it as alpha proto. Okay. Then based on the feedback, you make one more round. That we call it as a beta proto. You have to stop there. There is nothing like gamma proto or anything like that. You have to stop there. So why I am emphasizing on this is like, you have to put that much of effort into all these things. What can go wrong and things like that. Okay. So once that proto is done, then comes the pilot build. Pilot build is, finally you are going to make in volume. You may not have your manufacturing facility. If you don't have, I assume that you don't have. So this has to be manufactured in another lab. Okay. So as I said, that pilot build should happen in the final manufacturing location. Okay. So that is what has to happen. Why? I will tell the reasons later. Then compliance testing. Compliance testing is all the regulatory standard. That is the headache. There is no theory which explains about the compliance. You have to really practically do, and there are regulatory compliances. Why these compliances are required? You are coming up with a product, and when you switch on, the other products or similar products may not function because you are generating so many radiation and things like that. So there are some standards. And also, earlier TV and all, in the earlier days, in my old days and all, when the lightning comes, we switch off TV, fridge, everything. Now that is not required because the technology is, I am not saying you to keep on when the lightning comes, but that is not required. It is already complied to these type of things. So whenever you are developing these, for example, Boeing type of products, the hardware products, that will be subjected to all these testing. Like for example, I don't know whether you have seen, you made a good product, and you go for compliance testing, they will take a gun, that's the KV, electrostatic gun. It will create a lightning there, like through air. A spark goes into your open spaces, wherever connectors are there. Wherever some openings are there, they will put this gun. 11 kV and all. You can see that lightning or spark going in, your product dies. That's all. So if you have thought of this one, when you do the designing, what you can do is, when electrostatic discharge comes, you put a small diode, EST diode, which will take it to ground. Okay, so that your product will survive. So these things you have to think. Reliability testing. You are coming up with a product, for example, especially for aerospace and all, you are coming up with a product. How can you tell the warranty, life of your product? Because you have not used it. It's a new product. So one option is you go to some Jolster and ask him what can be the life, and he will tell 10 years or something you give. So that is not going to happen in science. So you have to, something called, you have to accelerate the life test. That is called HALT, highly accelerated life test. For example, I am developing some product, that pressure cooker, burn it for 2 hours. The pressure cooker means 85 degrees Celsius and 85% relative humidity. You burn it. You can even take reading when it is being burned, or you take out after 2 hours and test it whether it works. Okay, that will, from that data, you can find out what can be the life of that product. So that data is required for any of the products, hardware products, which you are developing for your thing. Okay. I think I have a lot to talk about. This is, how can we make designs manufacturable? This is one of the thing, design for manufacturability. That's what when you are going to do manufacturing, volume manufacturing, you are not going to sit with your soldering iron or your screwdriver and put it. These are all to be transferred to a manufacturing facility. Okay. So in the manufacturing facility, they may be using some automation, like laser cutting or some automated component placement and all. So when you do the design, all those aspects also to be taken care. Otherwise, you take the design there, they will tell that this is not manufacturable. You come back and again start from the scratch. I have lot of examples to talk about from the startups on that one. Design for testability. Testability is another thing. You are developing a product, you are manufacturing a product, for example. It starts from one stage, and when it reaches the other end of the table, the product is completed. So if you blindly send through all these stages, at the end, it can happen like the product is not working. Okay, so you lost everything. So for that purpose, when you do the manufacturing, at various stages, there are some test jigs, so that you can test up to that it is working, up to that it is working. If it is not working, do a rework and then take it. Okay, so for that, you have to give some provisions in the PCB or the product, so that you can test those things without affecting the existing product, because I cannot put some pin or anything like that and test it. Okay, so that aspect also you have to take care of that. Then design for assembly and complying to standard. So you may ask me, you show me a case study, because this is very important to show a case study so that you will understand. Let me, the idea here is I would like to design and develop a new generation ultrasound equipment. I am moving from fiber optics to the other one, healthcare. So I have a reference existing system. This is what is there already. So I want to design. So let me take you through the whole process of this one. I have some concept, because I have how it should look like. It should look like sleek and things like that is not very clear at that point of view. I will go to the proof of concept. I will be using normal display and bought out things and all to show my theory. I am using a different technology. I am not going to talk about that. Then I move to the design. All these designs are involved in that. Why I am showing here is like I am showing only the console. You can see as against the normal ultrasound console, which looks like grey color. You might have seen. But this time we wanted to come up with something different, black. Then light lit, because the new generation, okay. So light lit one, which was not there. And that we have done. Then I have put this color, that's a rubber. You never think like how this will be used, the ultrasound. Ultrasound, when I think those who have undergone, you can see that a lot of gels will be used before putting the ultrasound, right? So that gel may fall on this one, this console. Then water, coffee, whatever, and cleaning liquid, everything can fall on the console. So if I don't think in that way, like this can fall, I have to take care of that. So what I have done is like I have put a rubber layer there, so that even if something falls on, it will not get into the electronics inside. This is drained through that rubber part, so that I will save my electronics. Okay, so this you have to think of this one. So like that I did. Another thing is like this, the doctor or technician will be using the knob here. So he or she will be putting lot of pressure there. So when you put pressure, if the material can bend, it can create problems. So what you can do is increase the thickness of the material. Then the cost will go up, right? So what is the alternative? Alternative is you can put some ribs like that. Those who are mechanical, you will know. Instead of increasing the thickness of material, you can put some ribs like that, which will strengthen that area. Okay, so you need not put lot of material, just design, in the design itself you put a rib. So that is how you have to think. Why I am showing this case study is like, you can think of what are the aspects to be thought of when you do the design. It's not a very simple thing. I made the prototype, it can be 3D printed or whatever it is. Then I final assembly in the manufacturing facility. So here also another important thing is like, you are not going to the manufacturing fellow and talk and discuss and things like that. Your documents should tell everything. your technology transfer, not technology, basically manufacturing transfer will not happen through your voice. It should happen through your documents. That is also very important. I will cover that also. So you can see the compliance, the final product is made like this, which is very sleek and with a lot of new technology and all. I go for compliance testing. So you can see lot many things to be done. For example, I have seen some of you are working with underwater this thing like drone or something like that. So when you are thinking of that underwater drone, where will this be used under the water, right? Under the water means you have to take care of that aspects of what for example IP68 or something like that. I think that standard you have to think. So you have to really test on that one, put it under that one and then test it. Then when you are coming up with that, lot of other issues are thermal issues and not many aspects are. So here also you can see this has to be tested underwater. I think it was 65, IP65. Then we have to put all these things and then the reliability testing. One of them I am showing here, there were keys. You have to estimate what will be the number of times this key will, for example, power on key will be used. I will tell like a doctor will work a day, maybe 100 times he will press, multiply, 10 years it has to work, so 10 million times, something like that. So you have to physically press that switch for 10 million times and make sure that it still works. Okay, then only you can tell that this will work. For that you need not do yourself, you can make a small setup, we have made like that. It will go on pressing it that and test the switch. When the switch fails, it will give a number, what is the count. So from that you can estimate. So all these things to be taken care of, and as I said, all these are the main documents you have to transfer to the manufacturing people like that. Okay, so I think it will take a lot of time. So that's how it has become a commercial product here. So that was a case study. And you may ask, since it is Boeing, defense and aerospace, we have made lot of design. For example, one or two I will just tell. Lot of application in optical sensors. If you are working, see, optical and RF are some of the niche areas where only a few people are there, because it's not like 1 or 0. You have to really understand if I am getting this much power level, what it signifies. So that's why many people are not there. Those who are experts in RF and optic, they have gone up like anything. You can see many companies in India also, they are having very good sales volume, especially in defense and aerospace. I will tell only one example. We have come up with so many. One is here, torpedo release. When a torpedo is launched from a ship, the torpedo goes, okay. I was thinking like the torpedo goes off its own. It's with the guidance. It's not like that. There was a copper wire connected to the torpedo to the mother vessel, and all the communication is through that copper wire. Okay, so one of our defense area, since I was working in optical area, they came and asked us whether can you replace that copper with the fiber. The fiber problem is like, it is underwater, shark can come and bite, lot many issues are there. So you have to come up with, take care of all those things. Then when the torpedo is launched from the mother ship, it goes at some particular velocity in the water. So the spool has to unwind in that way. So that unwinding mechanism is very, very complex. It should not collapse. It should not bring in some kinks. It's a very, very complex one. So we came up with a machine, you can see, which can bring in that type of spooling structure. It's very, very complex. I am not getting into that, but these are all possible. Lot of opportunities available in this one. This can be in, I told fiber optics, but in other areas also it is there. So I always used to tell, like, whenever we have an idea, concept and all, we worship, Saraswati, but you have to slowly start thinking about Lakshmi also. I believe in women empowerment still, like they help us. So whenever you do something, you have to think both, not only research, but the Lakshmi side also, that is return on investment. This is another, we hate documentation, everybody hates documentation, okay, but fortunately, documentation plays an important role in product lifecycle management. This is very, very important. There are two aspects. One is like, as I said, your document should speak to others. Second one is when you are a small company, there will be some people, you will be employing, retaining people will be very, very difficult. They will jump after 6 months, the whole thing goes because there is no documentation in that. So you please insist, you yourself have to do, as well as you insist others to do the documentation. This is very important. I think especially for firmware, I am really scared of firmware, you know, we never get a proper documentation because documentation takes a lot of time than coding, I think. That's what I think. For me, if you ask me to do a coding, I can do, but if you ask me to draw the documentation, you know, the flow chart and all, I am, you know, really bad in that one. So, but you have to remember that. This is very important for you. Okay. Then when you are coming up with a product, you know, there is, you have to first come up with an engineering specification for the product. This is very important. Normally we keep everything in our mind, like what is there. So qualitative inputs in common language to quantitative engineering specification you have to bring. Okay. For example, the customer may say, you know, based on meanings expressed through words, collection results in non-standardized data requiring classification and all those things. But you have to transfer that into engineering specification. I think I have some examples. I don't know whether I have put it. Yeah. There was one qualitative requirement by the customer. He says like the user wants the, user means customer, wants the device shall not break even if it falls on ground. That's what he is going to tell. Okay. Immediately you have to ask a lot of questions. At what maximum height it may fall? Or is it from, you know, from top or from a man? Then what type of surface it will fall? Because you have to know where this will be used. Then what is the standard it has to comply with? You have to, there are standards for all these things. Unfortunately, all those things are already in place. In order to verify these requirements, practical drop test needs to be done. It is not like you are designing. You have to also verify and validate and show. So these are all required here. So I put in here, you know, for one of the product, you know, I came up with a complete specification. This is the standard it has to follow, all these things. I think those who are working in defense and aerospace is very, very, very important. Then engineering specification to product specification. That is something you have to do. Product specification document. I am always specifying document. You know, you can put must have, should have, nice to have and won't have. Sometimes, you know, you can put the feature but don't assemble it. So like that, you know, a lot of tricks you have to do here, and that's what you have to come up with. I am showing, like for example, if you have a product, you separate into all these things, subsystems, because one person is not going to develop the product, a team is going to develop the product. So you have electronics team, mechanical team. So unless you define very clearly what a mechanical fellow has to do, what a electronics fellow has to do, what a firmware fellow has to do, they will do according to that one, then you integrate, it will become okay. Otherwise, you know, you will get into again problems and all. So like that, you know, you have to do industrial design, what are the things you have to do, and regulatory standards, environment requirements, temperature cycling, and all those things you have to do. So this is a typical detailed product specification from concept which we have come up with, you know, computing specification, software components, and all those things you have to list down. You don't worry about this at the initial stage. Slowly when you develop, but you keep this in mind that this has to come out. Okay, it's not a very simple way of developing a prototype and showing to somebody and getting money, you know, getting investment. It is not like that. So yeah, you can see reliability, ruggedness, all those things I have put down for one of the products which we developed here. Yeah, design for manufacturing is another thing which I think this is actually a process of designing parts, components or products for ease of manufacturing with an end goal of making a better product at lower cost. See, if you don't think in design for manufacturability, you are going to get into problems like, you know, again and again iteration you will do it. The manufacturing fellow doesn't care about when you go with 10 units, you know, he is making thousands and 10,000s, you know. So you have to make him very comfortable when you go to him. So you have to do that, all the working on that. This is done by simplifying, optimizing, refining the product design. Then 5 principles normally we look at process. Whatever process you are doing, whether we can simplify that, design, material, environment, compliance and testing, what are things you can optimize. I am not saying like it is simplification, but optimize that one. For example, the manufacturing process chosen must be correct one for the product or part or product. One example is like injection molding. You know, if for example I am designing this one, This is injection molded plastic. This will cost, maybe the enclosure may cost 100 rupees. But if you want to make this injection molding, you have to make a tool, mold. That will cost maybe 50 lakhs. Okay. So that is how it comes. The part cost comes down, but the tool cost goes up. So unless you have volume, don't go for this. So you can go for other things like maybe thermoforming, then vacuum casting, which you can do 10 numbers, 100 numbers and all. Okay. So you have to identify that one. But when you do the design, you have to take care of that for a volume. Then actual drawing of the product, okay. Material is another one. You can't select anything. You have to be very careful. What are the mechanical properties, optical, if it is required, thermal properties, then electrical properties, flammability. For example, color, I always used to tell, when you come up with a very good product, you go to the customer, they will tell that I would have bought 10,000 if the color is black. Now you are coming up with a white color. That is a normal thing what you hear from the customer if they don't want to buy it. Okay. So this is how you have to. So you have to do enough exercise to know what the customer wants. Okay. So that is very, very important. I have shown many successful stories. I have a lot of failures also, but then environment, where this is going to be installed. For example, something you are going to install underwater. What happens, like corrosion and all those things will happen. So how are you doing the design? What is the material you are going to have? Another one, you are going to put on the sunlight. Sunlight, what happens is, like when you put UV light, the direct sunlight, you can see after some time it will become brittle and break it. You can see on many of the posts, it hangs like this one, many of the boxes. That is because of that. So you have to take care of that. What material is UV resistant? So that's how you have to take care of that one. So then compliance testing, this is one of the very, very difficult tasks. I always suggest you, I have many startups came up with a final product and it doesn't pass the compliance test. At that time, whatever expertise you have, it is very difficult to make it any changes. For example, if any radiation comes out, you can always probe that, but you have to put a metal sheet on that to suppress that one so that it doesn't come out. But there will not be any space because already the mechanical structure is done. That's why I am saying, like, these aspects to be taken care at the design. It is not an afterthought. Okay, so this is very important. So like that, this you have to do. I will rush. FMEA, failure mode. See, there is no product which will not have any failure mode. There can be many failure modes. So you have to list down, you have to imagine and list down what all can be the failure modes possible. Once you identify the failure mode, the first thing what you have to do is how to take care of that risk. Okay, maybe by changing something. For example, a user healthcare thing, you have to make a very smooth surfaces, sharp, not sharp, actually the curves, smooth curves and all. It should not hit the patient and it will injure, all those things. So like that, you have to really, and redundancy. Those who are working in aerospace defense, if you see the aircraft, the engines are there. Normally they put 2 engines, right? That's what we know. But 2 engines can be from different vendors. For example, the firmware, the software what they load, it can be by the 2 different vendors. Otherwise, it can happen like same time it may fail, due to some bug in. So you have to select from 2. So similarly, when you are coming up with a product, you have to also think of redundancy. For example, if one of the silicon fails, what happens? You have to put some fail-safe mode so that it will be taken care of. Because these are all very, very difficult thing. Like if it fails, then a lot of problem. Then design to cost. This is another one. Cost to be made as a specification to meet. I told you. So why I am saying is this is like when you are putting the specification, you have to put the cost also as a specification. So you have to meet that. So you have to, when you do the design, you will think whether I will be able to meet the cost. For example, Wi-Fi module and all, no easily available modules are there. You can just plug in, but it will cost much. Can we get away from that and then you use a chip or something like that, so that you can save. So those are all some of the aspects. No over designs, never ever do any over design. Whatever is just needed, just required features. Alternate design methodology. I think I have one example here. One of the customer, they wanted to come up with a vehicle identifier for the 2-wheeler. Normally we have for 4-wheelers, that you can click and the door will open, you can identify the vehicle. But when you look at the railway station and all, thousands of bikes are kept. and you don't know, all are looking same, your bike also will look with the other one, how to identify? So they wanted to come up with a vehicle identifier, like the car one. But here the requirement was can be as high as 1,000 rupees. After that, nobody is going to buy. So when we did the design, the bill of material cost itself was coming 1,200 rupees or something like that. Then what we did was like we removed the chips solution. We came up with a oscillator using a transistor and a coil of our own. Then only you can meet that product cost. So you have to think in that way also. It is not like always available ready-made solution you can use it. Of course, the risk is less in that way. You need not, you will pass through the compliance test and all, but you have to be very careful. Firmware, software, replacing hardware. This is one solution. I think many people are working on that. Can we replace some of the hardware using firmware or software? So that is also soft solutions, whether you are able to do that. With that, I think, okay, one case study is there. One of the startup, you may be knowing, I think, they were stuck in realizing a manufacturable design. What they have done is, this is for a, I'm not going to explain everything, but for a, to avoid bed sore for, the ailing patients. To avoid bed sore, in hospital what is done is like, the nurses, they will come and give some space, like move a little bit and also that once in a while. So whether that can be automated. So they have used air pillows and came up with this one. This is not going to be a manufacturable solution. So from our side, what we did was like the whole thing we transformed into a bed, and with air pumps here, and the required zones can be inflated or deflated. Okay, so that it will give the same effect on that one. So this is manufacturable. Okay, you can go to any manufacturer, you can get things done. So that's what you have to think. You have to think beyond your imagination there. This is another one. I don't know whether IIT Madras or something. They came up with the crutches, very innovative way, and it was not getting the proper expectancy. So the feedback, we have done a redesign on that one. It's already a product, but we did a redesign on that one. A simple redesign. So you can see how we could change the thing. So these are all coming from the experience. I can't tell like every time, but for you, when you are deep into your product, I think that can be done. I am coming to an end here. Product cost. This is one thing what people tell, like I am getting a product, for example, this one, Epson. I am buying for $100. If I open it up and see, the bill of material cost comes to $50. So I can make it, why don't I make it here and then sell it? That is not correct approach, because product cost consists of not only bill of material cost, inward freight cost, because components to be imported, customs duty you have to pay, conversion cost, the assembly and all, because soldering or whatever, screw, nuts, fasteners, assembly and testing cost, packing brochure cost, R&D, development, tool cost, amortization you have to do. Then also the selling cost will be product cost of this one plus profit plus the distributor margin. For example, you may not be directly selling, there may be some distributor. So one example I think I have here, a real example. You can see the direct material BOM cost was only 65%. There is no margin for the only profit. I put some 9% or something like that. So you can see that's how it comes in. There are yield loss, because whatever you make may not work. There will be some failures there. So out of 100, 2 maybe may not be working. So you have to take care of that also. So never ever think like a bill of material cost is the product cost. This you have to really understand that. The relevant quality certifications for mainly for Boeing type of product, ISO 9001 you have to have, AS 9100 you have to have, NATCAP for any of the manufacturing, Semilac if you want to sell it in Indian defense, you need to have Semilac, CMMI level 5 I think for software if you want to have, it can be 3 also. So as a summary, prototype development completion is only 30% of the whole job. You can see what are the stages involved if you want to convert an idea to a product. I am not here to scare you, but you have to be aware of that. That is better. So ignorance is not a good thing here. Design for manufacturability, regulatory compliance shall not be an afterthought. I told you have to plan like first time right. I will put a lot of time on that one and then come up with the product. Okay, that's what. take help of hands-on vendors if it helps, because there are many people in the country who have done these type of burned their fingers and learned. Okay, it's only through burning you will know. And of course, excellent opportunity for startups. For I think that's what I think exactly. 2 more minutes for any.
But we are going for redesign.
Yes.
So like, how do we come to the conclusion? Like because when I design my product, I do a lot of simulations. We do FE analysis, a lot of performance analysis we do.
Yeah.
And then only we go for manufacturing.
Yeah.
Here the product has been designed such way, it has been deployed.
Yeah.
But we see like there is a need for design. I accept that is the major case.
Yeah.
But like how did we?
Yeah. What we did was like we also first did a simulation only. Whatever available thing, we measured that one and simulated. We could get the same result what they were getting. Then we refined on the design. Again simulated. Then we did a real validation, hardware validation, like for example 130 kg I think some weight we have put and pressed and things like that. So that's how we have to come up.
But after that we deploy the product in the market.
Yes.
But still we see like the product does not require some more redesign.
You have to again do it that one.
From the market, like how to?
See, what we are getting is we got the market feedback, like it works only up to this. Okay. Then first you have to recreate the same thing, validate what they are saying. Okay. That is not maybe because of your manufacturing issue. Yes. Maybe the material they have changed it. Okay. Or when you do the manufacturing, you go to a local shop, they will do something, we don't know. So like that you re-simulate and validate that the current failure is correct. Then you work on that one.
So for us here the feedback is the customer.
Yes. Yes.
And one more was like we are talking about like RF and
yes.
So like today we are working with a lot of sensors, and today there's a talk about electromagnetic pollution.
Yeah.
So like is it appropriate like we have too many sensors close together?
Yeah.
And we will have
this is one concern I also have, but everybody is saying like SAR measurement. That is called SAR measurement within the regulatory compliance. So absolutely nobody has proven that it is. We always tell like if you put a antenna, the telecom antenna, the birds are flying away, bees are going away and all. But there is no scientific proof on that one. Off the record, it can be an influence of the chip manufacturer. I don't know really whether it is there, but no proven thing.
My question is is there an impact on the performance of sensors like if they are?
No. If you are within that standards, you are complying to standards, there will not be an issue.
So like between sensors will not have electromagnetic.
Yes. I always advocate for optical connection. Yeah, but if it is possible, sometimes it is not possible.
Because we talk about wireless.
Yeah.
So they try to put a lot of wireless.
Right.
But we get a lot of noise.
Right. See, there was an example here in US, I think. Energy meters were read using RF. The fellow will go through the road and he will get all the reading, like how much it is. He need not come to the compound and get dog bites and all those things. Okay. So in that way, there was one county in US, they told they don't want. Some pregnant woman and all them, they sued saying like that is because of, So they told like we don't want. So these things are there, but I have not seen anyone practically proved using regulatory compliance. Yeah.
Thank you.
Sir, you mentioned very explicitly about the compliance standards, like when we are designing anything. To start with, any of the innovator might not be aware of such compliances. So what do you suggest that, like how to get aware of the compliances that would be needed?
Right. That's a very good valid question, because initially you will not know. The best way, 2 ways are there. One is, you try to find out competitive products, okay, globally available, something similar to you. So you can look at what are the standards they have already complied to. So you can get those numbers. So that you can take it as a reference. Otherwise, there are a lot of experts also in the regulatory compliance. If you tell what is your product and all, it will take some time, but they can tell what are the. It is not like first time you are coming up with a product, of this one. There will be competitive products. You look at their compliance, then you can follow that.
Thank you, sir.
Yeah. Yes.
Hi, sir. Okay, sir. So my name is Rashid. We develop new gas turbine engines.
Yeah.
So it's all about innovation and invention. So an innovation followed by invention. So we are solving multiple problems actually. around 17 problems.
Okay.
So we are like, we have to go for like one or two problems actually, we have to concentrate. And but our customers are like, it is not easily available.
Yeah.
So through our product development, like, how can we take those things like,
Yeah, see, probably what we normally do is we try to do an analysis with weightage. For example, this feature may be required by the customer, but the other, that's what I mentioned, like must have, what is that called? There are some, nice to have. So like that need not have type of thing. So you can give some weightage and focus on those things, must have thing. Because without that you cannot anyway go, but the other nice to have and all you can always, manage with them. Yeah, but you need to really work with the potential customers. There'll be, I think, people, even if you are turbine engine and all, ISRO and all those people are very, very open now. You can always go and meet them, discuss them and all that. Yeah.
okay, sir, thanks.
Okay, thank you. Okay, thank you.